morning, students. I hope you all are safe at your home. From today, we are starting physics video lesson. So welcome you all. We are starting chapter 2, that is physical quantities and measurement. Why I am starting chapter 2? Because already all these topics you have studied in class 7th. This is just basic for you. In class 7th, chapter 1, unit 3. The chapter was measurement of density and speed. So, some common topics we will study here. Today we are going to cover these topics. Definition of density, unit of density, determination of density of a solid using a measuring cylinder, density of an irregular solid using Eureka-kin, density of a liquid using density bottle, and some observation and calculations. Definition of density. The mass per unit volume of a substance is called its density. If m is the mass of an object of volume v, where m is the mass of the substance and v is the volume of the substance or that object, then d is the density of that object. D is equal to m upon v, where d is the density mass of the substance or object, v is the volume of the object. Unit of density. Let's talk about the unit of mass and volume. Unit of mass in CGS, gram, in SI system it is kilogram. Unit of volume in CGS, centimeter cube, and in SI system, cubic meter. Put these units in the formula of the density, that is density is equal to mass upon volume. What we are getting? Gram per centimeter cube. This is the unit of density in CGS system. Kilogram per cubic meter. Unit of density in SI system. Let me tell you some examples of density of some substances like that in solid. Density of a cork, that is 250 kilogram per meter cube. 250 kilogram per meter cube. This is the density of a cork. And in liquid water, density of water, it is 1000 kilogram per meter cube, and in CGS system it is 1 gram per centimeter cube at 4 degrees Celsius. So these are the examples of density of the substances. Determination of density of a solid by using a measuring cylinder. What is that required materials we need? Measuring cylinder, a cotton thread, a solid for which we need to determine the density. Okay, and water. Determine the density of a solid, we must know the mass and the volume of the solid. If we know the mass and the volume of the solid, we can put this value in the formula, that is D is equal to m upon v, and we can determine the value of the density. So how we will determine that? The mass of the solid is determined by a physical balance very accurately. Mass we can determine using the physical balance. Using this you can measure the mass of the solid. Let it be m grams. Now volume. Take a measuring cylinder. This is a measuring cylinder which we are using for this experiment, and pour in it some water. Pouring some water. In order to find the volume, take a measuring cylinder and pour in it some water. Record the volume of the water from the mark on measuring cylinder. What is the volume in this case? Volume of the water? Here it is 50 centimeter cube. Now, tie the given solid to a fine thread. This is a solid tied with that fine thread or cotton thread. And lower it gently in the measuring cylinder. This thread, lower it gently in the measuring cylinder inside the water, such that it is completely immersed in water. In this condition, this solid is immersed in the water. Now we have to record the new level of the water. What is the new level of the water? 75. Initially it was 50 after immersing that solid in this water. What we are getting new reading, that is 75 centimeter cube. Now volume of the solid will be 75. This is the final reading minus initial reading was 50. What is the volume? That is 25 centimeter cube. This is the volume of the solid. Now, using physical balance, we had determined the value of the mass of the solid. Now, we know the volume of the substance, volume of the solid. Put these values, means put this value of mass and value of volume in the formula. It is D is equal to M upon V. After calculation, we can get the value of the density. Unit will be gram per centimeter cube. Measurement of density of irregular solid using Eureka can. Here D stands for density. Density of irregular solid we have to determine. Okay, again we know the formula that density is equal to mass upon volume. We have to determine the mass and the volume of the irregular solid. We have to put that values in the formula and we can get the density. Here we have to use Eureka can. This is Eureka can. This is Eureka can. Let me define it. A Eureka can consists of an iron vessel which is provided with a spout. This is spout or bead. This is spout. What we have to do in this practical, let me tell you required materials. Eureka can, measuring cylinder, a stent, a thread, cotton thread, and an irregular solid. Start this practical. Fill the Eureka can with water till the water is at the point of overflowing. We have to fill it with the water. This is the maximum point. This is the point of overflowing. After this, this water will overflow. So you have to fill this Eureka can up to this point. Under the spout of Eureka can, place the measuring cylinder. Here we have to place a measuring cylinder under this spout or bead. The solid displaces. Now gently lower this solid in the Eureka can. This solid using a thread. Place, immerse it into the water. When it will immerse, this water will overflow and this will fill in this measuring cylinder. Okay. Gently lower the solid in the Eureka can. The solid displaces the water which flows out. The solid displaces this water and it flows out from the spout into the measuring cylinder. Record the volume of the water overflow. This gives us volume of the solid. Using this measuring cylinder, we have to measure that quantity of the or that volume of the water. The mass of the solid is determined using physical balance. Mass we know using physical balance. Volume we can determine using this measuring cylinder. This is the point. If, for example, this is 50 or 25, so the volume of the this solid, irregular solid, will be 25 centimeter cube. Like this, we have to put the value of the mass and value of the volume in the formula, that is D is equals to m upon 3. After solving this, we can get the value of the density in gram per centimeter cube. Measurement of density of a liquid by using a density bottle. For this, we will use the specially designed density bottle. A specially designed density bottle of capacity 50 ml is used for finding density of liquids. It is a small glass bottle having a close fitting around glass stopper at its neck. The stopper has a small capillary tube. This is the capillary tube. When the bottle is completely filled with some liquid and then stopper is inserted, then excess liquid rises up through the capillary tube and drains out. This is filled with the liquid. When we fix the stopper, the excess liquid will drain out. Then this in turn ensures that the bottle contains equal volume of liquid. When filled with liquid water, the different liquids, it can be kerosene oil, brine solution, alcohol, etc. Now we have to follow these steps for doing this practical method. Wash the density bottle with the distilled water and then dry it in hot air. Insert the stopper and find its mass on a physical balance. So initially, mass of the empty bottle, that is m1 grams. Next, fill the density bottle with distilled water completely and then insert the glass stopper. Wipe the bottle dry from outside and find its mass on a physical balance. Now, in second step, what we are doing, we are measuring the mass of the empty bottle plus water. Mass of the empty bottle plus water. That is M2G. By M1 and M2, we are differentiating the masses. Third step, pour off the water from the density bottle and dry it in hot air. Now, fill the density bottle with the given liquid. It can be kerosene oil or alcohol or etc. Insert the stopper and wipe the bottle dry from outside. Find the mass of density bottle and liquid on a physical balance. Now in this condition, what we are doing, we are measuring the mass of the empty bottle and liquid which is given. You can consider M3G. We have three masses. Mass of the empty bottle, initially in first step, mass of the empty bottle plus water, M2G, mass of the empty bottle plus liquid. What is that? M3G. Using this, we will do the calculation and observation based on this density bottle. Observation and calculation for measurement of density of this liquid by using a density bottle. Already we had done these 3 steps. Mass of the empty bottle, which is equal to m1 grams. Mass of the empty bottle plus water, second step, m2 grams. Mass of the empty bottle plus liquid, which is given to us for doing practical, can be alcohol. For example, it is alcohol. So the mass in that case, mass is m3 grams. Mass of only water. If we want to get the value of the mass of the only water, what we can do is m2 minus m1. This is mass of the empty bottle plus water. This is only empty water. If I subtract this equation 2 minus equation 1, what I will get? Mass of only water, that is m2 minus m1. Mass of the empty bottle minus mass of the empty bottle will be cancelled. We are getting m2 minus m1 gram. Remember, 1 gram of water is equal to 1 centimeter cube. So instead of gram, we are writing this centimeter cube. By this, we can determine the value of volume. So volume of water. This is the mass of the only water, which is m2 minus m1. So here we are getting volume of water, m2 minus m1 centimeter cube. Instead of gram, we are writing centimeter cube. Okay. Mass of the bottle. Here in this case, mass of the bottle will be m2 minus m1 centimeter cube, which is equal to, in this, mass of the liquid will be equal to mass of the water, because we are using the density bottle, which is fixed for the volume. So volume of the liquid will be equal to volume of the water, which is m2 minus m1 unit of the volume centimeter cube. By this, we don't know the mass of the liquid which we are using. For example, alcohol. Mass of the liquid. How we can determine? See this. Mass of the empty bottle plus liquid in third step, that is m3, and mass of the empty bottle m1. If I subtract this equation number 3 from equation number 1, I can get only mass of the liquid. So here by this I am getting mass of the liquid is equal to m3 minus m1 grams, because it is mass. So finally, we need to determine the density of the liquid. For this, we need to use the formula density is equal to mass upon volume. We should know, we have to find the value of the mass of the liquid, that is m3 minus m1 gram, and volume of the liquid. Volume of the liquid is equal to m2 minus m1 centimeter cube. We have to put this value in the formula. Let me show you. Formula of the density. D stands for density, M stands for mass of the liquid. Here mass of the liquid and volume of the liquid. Here density of the liquid. Mass of the liquid M3 minus M1 gram. Volume of the liquid M2 minus m1 centimeter cube. Unit will be gram per centimeter cube. What is this? Density of liquid, given liquid. Final formula we are getting density of liquid m3 minus m1 upon m2 minus m1 gram per centimeter cube. This formula you have to learn. Based on this formula, we have to solve some numericals. Numerical based on density bottle. We have to determine the density of the liquid using density bottle. So, question is, the density bottle weighs 20.25 grams when empty, 40.75 grams when filled with a liquid, and 50.25 grams when filled with water. Find volume of bottle and density of liquid. Let me tell you given values. A density bottle weighs 20.25 grams when empty. So the mass of empty bottle is 20.25 grams. Mass of the empty bottle when it is filled with water, that is 50.25 grams. Mass of the bottle when it is filled with liquid, 40.75 grams. These three values are given in the question. We have to determine volume of the bottle and density of the liquid. Okay, here initially by the derivation we have to determine the mass of the only water. How can you determine mass of the only water? Equation 2 minus equation 1. Why this mass of the empty bottle will be cancelled? Means 50.25 minus 20.25 grams. Here you will get 30 grams. It is 30 grams. Okay. We know that 1 gram of water is equal to 1 centimeter cube. By this we can find the volume of the liquid. Okay. Volume of only water. Mass of only water is 30 gram. 1 gram is equal to centimeter cube. So we can determine the volume of only water, that is 30 centimeter cube. Volume of only water is equal to volume of bottle, which is equal to volume of the liquid. That only we need now. That volume of liquid, that is 30 centimeter cube. Okay. Next, mass of the liquid only. If I want to get the mass of only liquid, here I know the mass of empty bottle plus liquid. If I subtract this equation number 3 from equation number 1, then mass of the empty bottle will be cancelled. Then only I will get the that mass of the liquid. 40.75 minus 20.25. Here we will get mass of the only liquid. Here we will get, by subtracting it, 20 point, you will get 20.50 grams, because it is mass. Okay. According to question, you have to determine that volume of bottle is 30 centimeter cube, and density of liquid. For density of liquid, we have to use the formula, that is mass per volume. According to the formula, mass per volume. We know the mass of the liquid, it is 20.50, and volume of the liquid, it is 30 centimeter cube.